Hello, my name is Eva Ahmed, and today I'll be talking about Lab 2, Lines of Charge. This lab expands on the principles that we discussed in Lab 1. The purpose of this lab is to understand how charged objects interact with their surroundings in more detail. We use the results of Lab 1 to estimate the magnitude of the charge on a tape, and do this by creating a computational model of two charged tapes that have an electrical and gravitational interaction. This model then helps us to determine the value of the net charge on the tapes as well as visualize this net charge. Lab 2 utilizes the same concepts we used in Lab 1, including Coulomb's law, the universal law of gravitation, electric field, and Newton's second law. Most important in this lab is Newton's second law, which relates force to mass and acceleration, as well as Coulomb's law, which relates force to the two charges that we use in this lab, as well as the distance between the two electrically charged objects. A quick overview of the experimental procedure we used in Lab 1. The first part of this procedure dealt with charging the tapes, while the second part of the procedure dealt with testing the charge on these two objects by bringing a hand close to it, then a pen, as well as a neutral object. The last part of this procedure was determining excess charge on a tape by placing two charged tapes near one another and observing their interactions in water. We used the force to determine the amount of charge on one tape. Note, we assume each U-tape has the same net charge and that all charges are treated as a point charge in this lab, with an equal distribution of charge across the tape. We also assume that air resistance is negligible. Here are some of the calculations we conducted in Lab 1. Today we will be focusing on charge on a U-tape and using this as a comparison point in computing the charge in Lab 2. When we treat the U-tape as a point charge in Lab 1, we got this value 9.8, 10 to the negative 9 coulombs. In this lab, we'll be treating the tape as a line charge, and we'll create a different value and compare that value to this value that we derived in the previous lab. Here was our initial code output that we got in Lab 1. As you can see here, the force of gravity and the force of electric field cancel each other out as the system is in equilibrium, and we are able to derive the charge of the tape as well as the electron deficit and the ratio of deficient electrons to atoms. We expand on this code in Lab 2 and create a more accurate representation of our charge. Note that in this computational model, we assume that each U-tape has the same net charge, and we treat each U-tape as a line charge with a uniform distribution of charge. We also ignore interactions between charges on the same tape and ignore air resistance. Here is a snapshot of the code that I created in order to create the computational model. First, we create a function for the electric field. Then, we create a line charge by iterating over a for loop in order to create this line charge. Then, we initialize the tape, a top tape and a bottom tape, in order to show that these two would interact and create the charge. Next, we simulated the tape as a line charge in order to calculate the electric field by again iterating over a for loop. Finally, we calculated net electric force and gravitational force and returned these two values. Here is my output for my computational model. As you can see here, I was able to return a magnitude of electric force and a magnitude of gravitational force that cancel each other out. This was done by doing sort of a trial and error process in order to supplement different charges in for Q in this previous part of the code. As you can see here, I used Q and Q0. And Q0 I set to my initial value that I got in Lab 1 as the charge, but we had to do some trial and error in order to make sure that these two charges cancel out and that the system remains in equilibrium. Finally, we answered some questions regarding the computational model. What if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. The point charge model yielded a charge for the U-tape of 9.8 times 10 to the negative 9 coulombs, while the line charge model yielded a value of 2.32908 times 10 to the negative 8 coulombs. The difference between these two values was quantified by a percent difference, which equated to about 137% difference between the two values. This showed a great deal of difference between the line charge model and the point charge model. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? So I said that these estimates differ on account of their varying methods of calculating the electric field of the top tape. The line charge model used in this lab demonstrates that the sections of the top tape match with sections on the bottom tape in exchanging charge. The magnitude of the charge for the line charge method is larger than the point charge method, but is also more accurate as it more realistically depicts the distribution of charge on an object. This concludes my discussion of Lab 2, Line of Charge. Thank you.